Hey, everybody. Uh, Coach Spears here. We're going to talk about the Goldilocks Zone and a couple of other things about our solar system today. So, here we go. So, there's this thing called the Goldilocks Zone, and it's based upon the old story about Goldilocks and the three bears. So, it's also known as the habitable zone, which is also the same as inhabitable. So, habitable means I can live there. I inhabit my house. I inhabit my city that I live in. Habitable is a place where life can exist. Okay. So, there's this thing, but it's also known as the Goldilocks zone. Okay. So, astronomers called it that because it's not too hot, it's not too cold, it's just right for liquid water to exist on the surface of the planet. So, the remember habitable zone, Goldilocks zone, same thing. Here's a neat little gift that I found that I think really summarizes this well. So, in the middle, you have the star, and then the red part is the too hot zone. So, if you're too close, it's too hot. If you're too far away, it's too cold. And that habitable zone is right where our planet happens to be. So water can exist on the surface of the planet, and we can live from that. So the habitable zone, you think about if you're too close to a fire, you get burned. If you are too far away, or so in this case, if the planets are too close, the water on the surface will boil away. Think about Mercury. Mercury is the closest planet to the star, to our star, and it's very hot on one side, very cold on the other. Okay. So if you're too far away, you can't feel the heat. So there's that sweet spot. Those of you who have been around a fire before, you know, hey, for my own personal comfort, I'm going to get close enough to the fire to feel it. And if I back up too far away, I can't feel it. So just think about it like that on a much larger scale. So in space, if you have a planet that's too far away, it's going to freeze. So it's going to be a big snowball. Okay. So that's not a really good place for us to find life. Okay. So we are looking for planets other than our own. So when I was a child, when I was y'all's age, we didn't know of a single other planet around any other stars in our solar system, or sorry, in our galaxy. We knew the galaxies were out there, we knew the stars were out there, but we hadn't identified any planets anywhere else in the universe. So once our telescope technology has gotten better, we have started to find those. Those types of planets are called exoplanets. So those are planets around a star other than our sun. As of today, once I just looked this up, they have discovered over 4,000 exoplanets so far, and they have also identified thousands of other stars that we could look at that have other planets, and that number is going to be larger. So this number 4,000, we went from none when I was a kid to we're at 4,000 now. I would anticipate that number to just simply continue to grow over time. Planet formation around stars seems to be relatively common. Okay, so for the possibility of life in space, astronomers are looking for places like Earth that we might colonize one day. So they're also searching for signs of current or past life. So far, we haven't found life anywhere else in the entire universe except right here on planet Earth. But what we do know is that water, for the type of biology that we see, that we can recognize, is the key to life so far. And there's a lot of reasons for that. But right now, just remember, water is the key to life. So when we look at Mars, there's a large amount of evidence that there used to be water on the surface of Mars. A lot of examples of water erosion in the ancient past of Mars. And Mars currently has an ice cap, kind of like the North Pole on planet Earth. And there's also evidence that shows there may be water trapped under the surface of Mars in the soil in the form of permafrost, which is it's constantly frozen. And so there's evidence of water there. So because of that, scientists think, hey, in our solar system, Mars might be the place where we might find at least microbial life. So when you say microbes, you're talking about microscopic single-celled organisms, that there might be signs of that in the soil on Earth, on Mars, because of that amount of water. We have several different landers and rovers that are orbiting Mars and rolling around on the surface of Mars, investigating that. So far, haven't really found anything to write home about as far as microbial life, but this is one of the reasons why you've heard so much about colonizing Mars and getting spaceships to Mars, men to Mars, astronauts, men and women. So that's something to keep on your horizon. So here's one little thing I want to throw out there for you too. So remember, the um, Goldilocks zone is about the distance a planet is away from the star so that there can be liquid water on the surface. That's how we define the habitable zone right now. So I say right now because in our solar system, we have a lot of moons around to the other planets, okay, especially our gas giants like Jupiter and Saturn. They have it's almost like a little mini solar system inside of our solar system. This is an example of a moon that's around Jupiter called Europa. Europa is covered in, I think, 20-kilometer thick sheets of ice. And there is strong evidence that underneath the ice of Europa, there are deep, liquid saltwater oceans. So Europa is a long way from us, and it's a long way for us to get out there. But this is an image that was taken by a satellite that we sent out there of the surface of Europa. This is another image of another moon out there called Enceladus or Enceladus. So as they're flying by Enceladus, they saw these plumes coming out. So as you look at that, I'll kind of zoom in on one of them. There's these cracks in the surface. It's an ice moon, so there's ice all over the surface. There's these cracks, these things blasting out of it. So they sent the satellite that they had sent into around that Enceladus to take pictures of it and analyze it, and they flew through that, and that's water vapor that's being blasted off into space. So when it flew through it, it's going to be frozen, of course, because it would have frozen when it came in contact with the vacuum. So there's water geysers blasting out of the surface of this moon, which would indicate that there are at least liquid oceans underneath the ice here as well. So the definition of what is the habitable zone, very well may change within y'all's lifetime. But right now it's liquid water on the surface. But the exobiologists now are thinking, even if there's not water on the surface, if you have that liquid ocean, even if it's underneath the ice, there may be a way for life to have taken hold there. We won't know until we get out there and drill down to the ice and put a little submarine in there and go looking around. Okay, so that's it for this today. Thanks a lot.